Everybody positions, please.
All right.
And then we move on.
So chapter 10. How about Calvin? Go ahead and read.
Calvin.
Draw a scatter plot for a set of ordered pairs. Compute the correlation coefficient. Test the hypothesis. H naught,
That's rho. That weird P is rho.
rho equals 0. Compute the equation of the regression.
Right. So these are things we're going to do in chapter 10.
Is that roll? Hold on. What?
So the introduction. Dennis, go ahead and read.
In addition to hypothesis testing and confidence intervals, inferential statistics involves determining what a relationship between two or more numerical or quantitative variables exists.
Great. Zach. The one who's looking.
Correlation determines if a linear relationship between variables exists. Regression describes the relationship between variables that is positive or negative, linear or non-linear.
Great.
Nice.
Ayla, go ahead.
The purpose of this chapter is to answer these questions statistically. 1. Are two or more variables related? 2. If so, what is the strength of the relationship? 3. What type of relationship exists? And 4. What kind of predictions can be made from the relationship?
Yeah, so let's look at those questions a little more in depth. Are two or more variables related? If so, what's the strength of that relationship? To answer those, we use what's called a correlation coefficient. It's a numerical measure to determine whether or not two or more variables are related and determine the strength of the relationship between or among the variables. So correlation coefficient, we're going to be using that. We're looking at that. Number 3, Michaela, go ahead.
Introduction. Number 3, what type of relationship exists? There are two types of relationships, simple and multiple. In a simple relationship, there are two variables, an independent variable, predictor variable, and a dependent variable, response variable. In a multiple relationship, there are two or more independent variables that are used to predict one independent variable.
Great, so we're going to be talking about a simple one with two variables. We remember chapter 1, we had dependent variables and independent variables, right? So the independent variable was the one we can mess with, we had control over, and depending on how we changed that, that affected the dependent variable. So that's, we're going to stick with that simple relationship for this chapter. And then we're going to also talk about predictions. So Shashank, go ahead and read.
What kind of predictions can be made from the relationship? Predictions are made daily in all areas. Examples include weather forecasting, stock market analysis, sales predictions, crop predictions, gasoline price predictions, and sports predictions. Some predictions are more accurate than others due to the strength of the relationship. That is, the stronger the relationship is between variables, the more accurate the prediction is.
Great. We're going to talk about scatter plots. That's a graph of the ordered pairs, x comma y, of numbers consisting of the independent variable, that's your x variable along the x-axis, and the dependent variable, the y variable, along the y-axis. So independent is always going to go along the x-axis. Here is an example. Car rental companies. So these are ordered pairs. So here is a car. Which one do you think we can have more control over? The number of cars we own or our revenue?
Cars.
Cars you own. Makes sense. So these are car rental companies. So a car rental company that owns 10,000 cars has a revenue of $1.5 billion. Everybody understand those two numbers go together? They're a point. The number 63.0, that many cars, goes with 7.0. That much money. Good? Mm-hmm. So those are ordered pairs. Good. So if we were going to draw that, so for the x-axis, I would need to go at least from what to what? What's my smallest number? 8.5, what's my largest number?
63.
So I might go like 0 to 70 or 0 to 65, something like that. My y-axis, I should always start at 0, right? Because remember that whole thing about misleading graphs in
Yes,
chapter 2?
non-zero.
Yeah, non-zero axis. So you should start at 0 and go up to 7. Let's see what they did. And make sure you label the x and y axes. That's worth a couple points on your exam. So here, cars in 10,000s. Over here we have revenue. And they went from, this is, looks like they went kind of from 0 to there. They kind of knocked them off. But here, and here looks like they went from 0 up to 7.75. So you can see like this one here looks like 63, comma 7, I think is that one, right?
Around that.
And see how this is sort of a positive relationship? It's going up. Everyone sort of sees that it's kind of like a line. Now you guys do a quick lab problem. So make a scatter plot, which means you're going to have an x and y axis. Number of absences is your x's. Final grade is your y's. Your x's need to go from at least what to what? What's your smallest?
2.
2, what's your largest?
15.
So maybe you go like 0, 5, 10, 15 across the bottom. Your y's, you should start from 0 and go all the way up to, at least up to 90.